All right, I think we're gonna get stuff started here. And I know this is with this wonderful snowstorm that we are experiencing right now. We're gonna have a great turnout. And we've got a wonderful speaker today, which I'm very, very excited about and proud about. And I'm glad to be able to have all of you be able to participate. I hope you pick up on some good stuff off of this. I'm Jason Bruns. I'm the director of the Minnesota State Engineering Center of Excellence. I want to thank you all for attending today, checking this out and seeing what it's all about. We try very hard to bring some pedagogy, some new stuff, some interesting stuff. I was able to meet Merredith at an ASEE conference, and she shared some good stuff there. And I had so much fun with it. I got to try it at Marshall after school program at the YMCA. So Merredith, thank you very much. My daughter thought it was absolutely wild and crazy how well those kids enjoyed themselves. So thank you. I'm glad we're able to get that. And I wanted to share this out with the state of Minnesota as well. A little housekeeping. There is a survey that is on the agenda. I sent the agenda out to all of you, and we'll also be popping the agenda into the chat room. Laura Lee will do that randomly throughout the day. So the video, we'll make the video available on our website. And so you can come back and watch that, or mention it to colleagues to come back and watch it and see what you can pick up on it. Those of you looking for professional development.
Well, what's up?
You can go ahead and contact me directly, Jason.Bruns, BRUNS at MNSU.edu. I think that's also on the agenda as well. So be sure to check that out and reach out to me. Give me a little bit of time. It takes me a little bit because I do it one-on-one for each person. So, but I can make all of that go. So let's get things rolling here. We got 34. I'm going to introduce our speakers. So Dr. Merredith Portsmore is a director for Tufts Center for Engineering Education and Outreach, and a research associate professor. Merredith received all 4 of her degrees from Tufts, a BA in English, BS in Mechanical Engineering, near and dear and close to my heart, an MA in Education, PhD in Engineering Education. She currently leads the Tufts Center for Engineering Education and Outreach, supervising grant administration, fundraising, and strategic planning. Her research interests focus on how children engage in designing and constructing solutions to engineering design problems and evaluating students' design artifacts. Her outreach work focuses on creating resources for K-12 educators to support engineering education in the classroom. So as a presentation overview, as a reminder, the description of this one is, how can we use books already in the classroom as a starting point for hands-on engineering? Initially funded by the National Science Foundation, Novel Engineering is an approach developed by Tufts Center for Engineering Education and Outreach that integrates engineering and literacy in K-8 classrooms. Books provident the clients and criteria and constraints for hands-on design projects that support students engaging in careful reading, analysis, and writing tasks. This session will provide an overview of the novel engineering approach to integrated learning and engaging participants in a short sample challenge. So with that, I'm going to hand it off to Merredith. Merredith, if there's anything that pops up, please know Laura Lee and I are right behind you to fly flank. Would you like questions? We'll save questions for towards the end, and we'll try to throw those into the chat if you could, and then we'll save those questions for at the end. Is that okay, Merredith, or would you like those just saved for the end?
Yeah, I think we can, if there's something burning right in the moment, we're gonna do some interactive stuff. So if you have questions or clarifications that you need, definitely throw them in the chat. We're gonna ask you to do a little bit of work this morning, so it won't be listening for 90 minutes because that's too much. So yeah, but if you have some bigger questions, those might be more useful to do at the end. All right. Well, thank you all for joining me on what I hear is a snowy day here, but you have a snowier day. I had the privilege of being in Minnesota this past June to do a workshop, and I'm so grateful for Jason and the Minnesota State Center for Engineering Excellence for all their support running that event. So many great folks and so many great people. So you heard a bit about all those funny details of what I do. I am also a parent. I'm also originally a Jersey girl, if that accent slips out every now and again, and married to a high school teacher who is teaching computer science. So lots of great connections there. And this has just always been my passion. I started doing engineering as an undergrad, and I liked it, but this idea of education was just so powerful. And I'm always so grateful for all the educators that collaborate with us on our projects and who allow us to come into their classrooms to try these new and exciting things. So novel engineering. Novel engineering came about in Massachusetts because we were starved for minutes to do engineering, right? There are there's only so many minutes in the day. And folks were thinking like, hey, what would be a way that we can accomplish dual goals so we can have children making and building and designing and doing those parts of engineering that we really care about, and also doing the ELA, English language arts work that they also need to be doing. And so it really made sense the more we dove into it, because books are such an amazing, rich context. So novel engineering is an approach that uses classroom literature, so there aren't special books for this, as a starting point for open-ended engineering design challenges. And we're going to talk more about engineering and design and literature today. But a really simple example is the one you see there, which is in Tales of a Fourth Grade Nestling, which you may or may not have read, kind of that key fourth grade book. There's a young boy, Peter, and he has a little brother who always gets into his stuff. They live in New York, and all Peter wants in the world is a pet. And he gets a pet turtle, and his brother is always trying to touch it, and he's worried about it. So all of a sudden we have a client, Peter, someone that has a problem, which is, keeping this turtle safe. And we have a context, right? We're in this little New York City apartment. We've got a 2-year-old, and how can we protect this turtle? And we don't want to just, put this turtle in a lead case, because that defeats the purpose of having a pet, right? That Peter wants to play with. So we think about different ideas that we could do. What could we make that would help Peter specifically? Not just keep a turtle protected, but help our character, still be able to play with it, and also keep it out of the reach of a 2-year-old, and also fits inside a New York City apartment. So that's an example of novel engineering, a really simple one, where by reading the book, we're getting all this information that helps us to construct our design solution. And that's a really interesting way of thinking about it, because helping a character means you have to really understand that character. You have to think about their wants and their needs and what makes sense for them in ways that help you get into the literacy parts. Because we don't just care about the engineering in this book, we also care about, can students find themes? Can they develop empathy? And all those pieces that go into our ELA and reading learning objectives. And what we found doing our work is there's a pretty wide variety of books that this works for, right? We have lots of books in our we did it primarily in K-8 classrooms that have these characters and situations where they have all these needs and attitudes and abilities, and they're in these complex settings, and there's resources and constraints. There are some books that this doesn't work super well for. Harry Potter does not need engineering. He has a magic wand. He's pretty well set. Right, like some of the fantastical books don't work as well. But these books, right, which often have characters that are close in age to our own students and that are set in all kinds of places, are really interesting spaces for them to dig into the book. And we see that kind of cross interest happening. Some kids are super into the building and, the book, but they get drawn back into the book to justify their design decisions. Some kids are really into the book, and so but they're a great resource for when we start building. So we see this kind of cross bi-directional, right? When we talk about integrated learning, we want to make sure we're prioritizing both disciplines. And so this is kind of what happens in a novel engineering project. The other really key thing when we were working on this project was to really think about, how precious time is in a classroom and what our busy educators are doing. And so we wanted to think about things that tied into what folks were already doing and could be the space. So at the center of it all is the book, because we know, at least in many classrooms, that's space and time that is reserved for reading that book. And as we read that book, if we start at the top there, right, we want to identify problems. What kinds of problems? There could be all kinds of problems in a book, and they're all valid. They might not all be great engineering problems, but they're all problems that we might want to talk about. Did a character feel sad or left out? Did a character feel neglected? And think about those. And then we go on to try and think, okay, what could we actually make to help this character? And here's where we segue into the engineering space, where we're thinking about what could we actually make with materials we have in this classroom, in this space, and try and test it out and give feedback. So making that, does our turtle protector actually roll up to the ceiling? Does it fit a turtle? If we have like a little toy or plush turtle, can we actually try out our ideas and see if they work? So not just a theoretical project, although that's all we'll do today, but one that actually functions. And then we want to have discussions about that. We want to improve those solutions. We want to show them off and say, oh, well, they don't work in this engineering way. That pulley, I can give you some ideas for how to do that. Or would Peter actually be able to use that? That's really big for a New York City apartment. What could we do to make it smaller so that it would actually fit? And then we have lots of time for students to make improvements to their physical artifacts, and then sharing. So we also have this kind of built-in piece on the other end, have students do more work. Could you write a letter to the character about how to use your design? Could you write a sample chapter for the book, or a piece for the book on how would the book be different if you had this piece? So instead of just writing for a random prompt, we have this really embedded prompt for writing pieces as well. It could also be, writing really great directions for someone else in the class to build your solution. So that's what it looks like. So novel engineering is an approach. So we'll show, I told you about a sample book. We're going to do a different sample book today, but it really is one that we were designing to say, hey, this could go into many, many, many kinds of classrooms, because we just need to find the literature that teachers are already using or teaching to make a connection. And so we've introduced a little bit about what it is today. And we want to try a short novel, Engineering, and then discuss any questions folks have about engineering and literacy in your classroom. And right, this looks wildly different when early elementary, right, where we might use picture books, which is what we're going to use today for the sake of time. And it looks different, right, when you might use a chapter book or a longer text in upper elementary or middle school. Across the board, folks have used all kinds of text. So obviously, we see a lot of fiction text because that's what is often in classroom. Folks have used excerpts from anthologies that they're required to teach. Folks have used nonfiction excerpts, to do that as well. Folks have used collections. Like we're going to design something, this book has a story about a baby bird, but we don't really know much about birds. We should probably read a bit more. So just thinking about ways that information and literacy come together. So to kick us off, though, I think one of the things that made this project resonate for me is thinking about what really impactful and exciting engineering design looks like in the real world, so that we're getting kind of those parallels when we use text. If I had a magic wand, I would love to send, my group of fourth graders out into the world to find a problem and to construct a solution for it. And that's an amazing thing to do with your classroom, but it has a pretty high overhead of the logistics of where we're going to find a problem. And many folks get that way, but it's not always feasible. So engineering looks like that in the real world. And then what we want to do today is draw some comparisons to how the text can function. Like, what if we were able to send our kids into their local community to do this? And I love watching this video because it's an interesting one. We would love to see other kinds of videos in this space, but this is the one that we have that works pretty well. So this is a story, and it's kind of funny because this is a story from a professor at MIT named Amos Winter. And the full disclosure is that Amos was actually one of my undergrad students for a long time. Well, not for a long time, for the normal 4 years. And this is something that he worked on designing, and it's really interesting. And we're going to watch this video. It's a TED Talk. It's not that long. And then we're going to put folks into breakout room to think about some questions. So one is, how does context, right? That idea of people, setting, situation, play a role in this particular engineer's design process? Because that, I think, is really important to think when we think about what role a book may play for students' engineering design process. So we're going to watch this video, and then I'm going to put you into breakout rooms. Oops. I'm going to put you into breakout rooms to think about what were some of the criteria for his design. What were some of the must-haves, the requirements, and what were some of the limitations? So, boiling in the back of your mind is this idea of context, and then we'll go on to do that. Let me just tab over. Actually, I'm going to stop sharing for 1 sec because I don't think I turned the sound sharing on. Clear sound, optimized for video clip. All right, here we go. All right, so we're gonna watch this video, and again, you're thinking about, how did this whole thing, what role did context play, and how, what were those actual requirements for this design, which come out of those contexts, right? Because we're in this particular place, designing for a particular group of folks, they have different needs than other groups may have. Do this.
Living with a physical disability isn't easy anywhere in the world. But if you live in a country like the United States, there's certain appurtenances available to you that do make life easier. So if you're in a building, you can take an elevator. If you're crossing the street, you have sidewalk cutouts. And if you have to travel some distance farther than you can do under your own power, there's accessible vehicles. And if you can't afford one of those, there's accessible public transportation. But in the developing world, things are quite different. There's 40 million people who need a wheelchair but don't have one. And the majority of these people live in rural areas where the only connections to community, to employment, to education are by traveling long distances on rough terrain, often under their own power. And the devices usually available to these people are not made for that context, break down quickly, and are hard to repair. Now, I started looking at wheelchairs in developing countries in 2005 when I spent the summer assessing the state of technology in Tanzania. And I talked to wheelchair users, wheelchair manufacturers, disability groups. And what stood out to me is that there wasn't a device available that was designed for rural areas that could go fast and efficiently on many types of terrain. So being a mechanical engineer, being at MIT and having lots of resources available to me, I thought I'd try to do something about it. Now, when you're talking about trying to travel long distances on rough terrain, I immediately thought of a mountain bike. And a mountain bike's good at doing this because it has a gear train. And you can shift to a low gear if you have to climb a hill or go through mud or sand, and you get a lot of torque, but a low speed. And if you want to go faster, say on pavement, you can shift to a high gear, and you get less torque, but higher speed. So, the logical evolution here is to just make a wheelchair with mountain bike components, which many people have done. But these are two products available in the US that would be difficult to transfer into developing countries because they're much, much too expensive. And the context I'm talking about is where you need to have a product that is less than $200. And this ideal product would also be able to go about 5 kilometers a day, so you could get to your job, get to school, and do it on many, many different types of terrain. But when you get home or want to go indoors at your work, it's got to be small enough and maneuverable enough to use inside. And furthermore, if you want it to last a long time out in rural areas, it has to be repairable using the local tools, materials, and knowledge in those contexts. So the real crux of the problem here is, how do you make a system that's a simple device but gives you a large mechanical advantage? How do you make like a mountain bike for your arms that doesn't have the mountain bike cost and complexity? So as is the case with simple solutions, oftentimes the answer is right in front of your face. And for us, it was levers. We used levers all the time in tools, doorknobs, bicycle parts. In that moment of inspiration, that key invention moment, was when I was sitting in front of my design notebook and I started thinking about somebody grabbing a lever. And if they grab near the end of the lever, they could get an effectively long lever and produce a lot of torque as they push back and forth, and effectively get a low gear. And as they slide their hand down the lever, they can push with a smaller effective lever length, but push through a bigger angle every stroke, which makes a faster rotational speed and gives you an effective high gear. So what's exciting about this system is that it's really, really mechanically simple, and you can make it using technology that's been around for hundreds of years. So seeing this in practice, this is the leverage freedom chair that after a few years of development, we're now going into production with. And this is a full-time wheelchair user. He's paralyzed in Guatemala, and you see he's able to traverse pretty rough terrain. And again, the key innovation of this technology is that when he wants to go fast, he just grabs the levers near the pivots and goes through a big angle every stroke. And as the going gets tougher, he just slides his hands up the levers, creates more torque, and kind of bench presses his way out of trouble through the rough terrain. Now, the big important point here is that the person is the complex machine in this system. It's the person that's sliding his hands up and down the levers, so the mechanism itself can be very simple and composed of bicycle parts you can get anywhere in the world. And because those bicycle parts are so ubiquitously available, they're super cheap. They're made by the gazillions in China and India, and we can source them anywhere in the world, build the chair anywhere, and most importantly, repair it, even out in a village with a local bicycle mechanic who has local tools, knowledge, and parts available. Now, when you want to use the LFC indoors, all you have to do is pull the levers out of the drivetrain, stow them in the frame, and it converts into a normal wheelchair that you can use just like any other normal wheelchair. And we sized it like a normal wheelchair, so it's narrow enough to fit through a standard doorway. It's low enough to fit under a table. And it's small and maneuverable enough to fit in a bathroom. And this is important so the user can get up close to a toilet and be able to transfer off just like he could in a normal wheelchair. Now, there's 3 important points that I want to stress that I think really hit home in this project. The first is that this product works well because we're effectively able to combine rigorous engineering science and analysis with user-centered design focused on the social and usage and economic factors important to wheelchair users in the developing countries. So I'm an academic at MIT, I'm a mechanical engineer, so I can do things like, look at the type of terrain you want to travel on and figure out how much resistance it should impose, look at the parts we have available and mix and match them to figure out what sort of gear trains we can use, and then look at the power and force you can get out of your upper body to analyze how fast you should be able to go in this chair as you put your arms up and down the levers. So as a wet behind the ears student, excited, our team made a prototype, brought that prototype to Tanzania, Kenya, and Vietnam in 2008, and found it was terrible because we didn't get enough input from users. So because we tested it with wheelchair users, with wheelchair manufacturers, we got that feedback from them, not just articulating their problems, but articulating their solutions, and worked together to go back to the drawing board and make a new design, which we brought back to East Africa in 2009, that worked a lot better than a normal wheelchair on rough terrain, but it still didn't work well indoors because it was too big, it was heavy, it was hard to move around. So again, with that user feedback, went back to the drawing board, came up with a better design, 20 pounds lighter, as narrow as a regular wheelchair, tested that in a field trial in Guatemala, and that advanced the product to the point where we have now that's going into production. Now, also being engineering scientists, we were able to quantify the performance benefits of the leverage freedom chair. So here are some shots of our trial in Guatemala, where we tested the LFC on village terrain and tested people's biomechanical outputs, their oxygen consumption, how fast they go, how much power they're putting out, both in their regular wheelchairs and using the LFC. And we found that the LFC is about 80% faster going on these terrains than a normal wheelchair. It's also about 40% more efficient than a regular wheelchair. And because of the mechanical advantage you get from the levers, you can produce 50% higher torque and really muscle your way through the really, really rough terrain. Now, the second lesson that we learned in this is that the constraints on this design really pushed the innovation. Because we had to hit such a low price point, because we had to make a device that could travel on many, many types of terrain, but still be usable indoors and be simple enough to repair, we ended up with a fundamentally new product that is an innovation in a space that really hasn't changed in 100 years. And these are all merits that are not just good in the developing world. Why not in countries like the US too? So we teamed up with Continuum, a local product design firm here in Boston, to make the high-end version, the developed world version, that will probably sell primarily in the US and Europe, but to higher income buyers. And the final point I want to make is that I think this project worked well because we engaged all the stakeholders that buy into this project and are important to consider in bringing the technology from inception of an idea through innovation, validation, commercialization, and dissemination. And that cycle has to start and end with end users. These are the people that define the requirements of the technology, and these are the people that have to give the thumbs up at the end and say, yeah, it actually works, it meets our needs. So people like me in the academic space, we can do things like innovate and analyze and test, create data, and make bench-level prototypes. But how do you get that bench-level prototype to commercialization? So we need gap fillers like Continuum that can work on commercializing. And we started a whole NGO to bring our chair to market, Global Research Innovation Technology. And then we also teamed up with a big manufacturer in India, Pinnacle Industries, that's tooled up now to make 500 chairs a month, and will make the first batch of 200 next month, which will be delivered in India. And then finally, to get this out to people in scale, we teamed up with the largest disability organization in the world, Jaipur Foot. Now, what's powerful about this model is when you bring together all these stakeholders that represent each link in the chain, from inception of an idea all the way to implementation in the field, that's where the magic happens. That's where you can take a guy like me, an academic, but analyze and test and create a new technology and quantitatively determine how much better the performance is. You can connect with stakeholders like the manufacturers and talk with them face to face and leverage their local knowledge of manufacturing practices and their clients, and combine that knowledge with our engineering knowledge to create something greater than either of us could have done alone. And then you can also engage the end user in the design process and not just ask him what he needs, but ask him how he thinks it can be achieved. And this picture was taken in India in our last field trial, where we had a 90% adoption rate where people switched to using our leverage freedom chair over their normal wheelchair. And this picture specifically is of Ashok. And Ashok had a spinal injury when he fell out of a tree, and he had been working at a tailor. But once he was injured, he wasn't able to transport himself from his house over a kilometer to his shop in his normal wheelchair. The road was too rough. But the day after he got an LFC, he hopped in it, rode that kilometer, opened up his shop, and soon after landed a contract to make school uniforms, and started making money, started providing for his family again.
हाँ, फिर दूसरे दिन से मैंने यहाँ आया, घर आया, एक दिन रेस्ट किया, फिर उसके नेक्स्ट डे पे मैंने ये दुकान वापस डाल आ गया था उस दिन, फिर यहाँ तक आप पहुँच गया था इससे। हाँ, बढ़िया। फिर दुकान डालने के बाद तो फिर अब रेगुलर।
And thank you very much for having me today.
All right. So I want to give people a chance to talk, so I'm just not talking at you for 90 minutes. So right, you got to see the video, you got to see, you know, kind of the people, the setting, and the situation. So that's what we want in the back of folks' mind. And then we're gonna break up into groups to talk about what are some of the criteria for this design. You know, we have this context. What did it mean in terms of what we needed to make? This is parallel in many ways to what we want to do with books. And so to do that, I was going to try Jamboard. I know some people are on their phones, so we'll do the best we can here. Maybe just add your ideas into the chat that way. where, just right on here, right, you can throw down little Post-it notes about what folks think. We're going to do 3 breakout rooms. It's super similar to Google Slides if you've used it, but this way we can have some smaller discussions, and I'll peek into the rooms to see how things are going. I'm going to put this link in the chat for those who have, where my chat go? There we go. For those there. And we'll be in there for just about like 7 or 8 minutes, just thinking about this. And if there's other things that struck you about the video, feel free to include those as well. All right, so now I'm going to do breakout rooms. Welcome back, folks. We're just letting the breakout rooms close, suck you through the portal. It always feels a little bit like Harry Potter. Suck you into this room. Fantastic. Well, thank you all. I know you are juggling lots of things today. So however you can participate, we love having you. Yeah, group 1 came out with a lot of great criteria. Does anybody from that group want to share something about what y'all were talking about? I know it's a lot of pressure. I'm living for these pink questions. I actually haven't had these before. I've shown this video a lot of times. And I'm really interested about this idea for kids too.
There was a lot of great input by everybody in the group, and I think that helped us come up with not only the criteria, but then also a lot of springboarding to other ideas of additional constraints that maybe weren't even thought about in the video or presented in the video. And then the conversation just kind of rolled from there. So that's where some of the pink Post-its came from, where those were just additional thoughts that we had in addition to what was being said about the original criteria.
Yeah. And I see a lot of criteria that came from the place, right? Like this idea of cost, this idea of what kind of people are going to use it. They're not going to have 2 wheelchairs. And I think it's super interesting, this idea of the working for kids, right? They definitely, which I think is always interesting, right? They definitely do boundaries around this product. It is not doing that, right? It definitely looks like it's designed for an average size adult in those contexts. And so, yeah, so that's an interesting idea, right? Should we expand this so that it includes more people? Is it worthwhile to kind of put some guardrails and boundaries on design? So you're like, yeah, we don't think we can do that as well if we include all of these things. So it's it's what I love about engineering, is there's so much problem scoping, right? There's so much trying to figure out what is the problem I'm going to solve. I have this big question of how do I help people with disabilities in the developing world? But I have to actually figure out what that means. And it's a cool kind of thinking because it's the kind of problem solving we see everywhere. How about group 2? Anything that y'all want to share from your discussion?
Well, I'm a wheelchair user, and I was injured back in 2009, and we talked about, and one of the things that happened to me recently is I wore my shoulders out, and that's because of the mechanical use of my shoulders compared to how I was using my wheelchair. And now I use an electric, but ergonomics is one of the big things that come up with constraints, because that forward pushing, when you go forward, you think push forward. It needs to be more like a rowboat. So when you're pulling, you go forward. So that is actually that action actually strengthens your shoulders. And we also talked about we had another member in our group that they had a child injured in a bus accident, and they don't really talk about, as the child gets older, you got to buy more stuff. We have that happen in our school too. We have several students in wheelchairs, and they have to upgrade so often. I'd also like to share that we didn't get the premium Freedom chair here in the United States. We got the same kind of chair, and the cost here in the United States is around $3,000. And if it's sold through insurance, then that price doubles.
Wow, thank you all so much for sharing, especially for sharing your personal experiences and pointing out the holes, right? There are still holes in this design and this process, and some that are directly tied to capitalism. Yeah, it's really powerful. And I think, right, in a beautiful TED Talk we get, we erase some of those things that you were foregrounding, Joel, that it requires you to have this ability to use your arms and use them in particular ways. So, right, you guys are identifying more kind of limitations to this design, which, right, we want our designs to be as inclusive as possible. And some of these we should take up, and some of them might be hard to take up. But they're really good pushes and really good information that comes from the community and the context and talking to folks. And group 3, maybe I know Jamboard is funny to use, especially depending on what your device. Anybody from group 3 want to share?
Sure. We didn't necessarily do this assignment focused on the Jamboard. We just had a lot of discussions about just the idea of this using either like stories, or even like the TED Talks might be a good fit for high school as far as like ways to introduce problems to have students think about, and probably that could help, get more people on board for doing this kind of engineering project in there, especially like down at the elementary level where reading is such a huge focus as far as what time is expected to be spent on.
Great. Yeah, thanks. I just love, my favorite part about engineering is just the messiness. I think we give kids so many problems that have one right answer, which isn't true in the real world, right? Like, so that idea of that our future citizenry is weighing like constraints, there's trade-offs here. There were trade-offs made in this design, and trying to figure out where that happens, as well as this idea that there could be multiple possible solutions, feels really a powerful thing to give students, not only for their engineering learning, but also for them as citizens, right? That there could be different ways to think about this, as well as like for these, raising the bar on who we include in the design process. We won't do it today, but right, we all know there are so many designs where, as we talk about AI, all kinds of things where we didn't have enough representation in the design process, and they came out not serving all people. So some really big ideas nested inside some of our other ideas. But let's get a little bit more chance to play here. Let me go back to my slideshow. Such a great group. You guys are there. This is one from another one, right? This like idea that this has to work in this environment. And what's always powerful about this video for me is that when we think about things, we have a long history of engineers going into context and being like, here's a great solution, but then it's not repairable, right? That the materials and the local knowledge doesn't allow, this water pump or this other solution to be continually used. And this is really powerful and important. And then also, I think, broadens who we think participates in engineering, because we know we have students who, love to do the making, or they're really powerful in the calculations, but this consideration of users is this other really important space in engineering. And I think foregrounding it broadens who thinks that they are welcome and invited and can contribute in the engineering field. And you guys highlighted all the rest of these. And this idea of the users is really powerful. So we want to do a little novel engineering. And And of course, if we were all together, Jason can attest, there'd be piles of materials and recyclables and tape and all kinds of cool stuff. We do this with whatever we have. Yeah, the idea is that it's low cost, right? I empty out I'm always saving my egg cartons and my toilet paper rolls and little piles around my house to do these things so that we can do it with any classroom at any time. And that's what we would do, but today we're going to kind of just do it as a theoretical one. But I want to do a book with you so that we can see how much is just in a picture book. And so this is Peter's Chair by Ezra Jack Keats that we'll read together. And then what we do with students is kind of think of an empathy map. What do we know about this character? So that we can go on to think about what, as engineers, we might do to help solve Peter's problem. And have you guys actually use the next couple pages of Jamboards to think about what could you possibly make with, those kind of those craft and recyclables that they're easily accessible. I will say that in some novel engineering spaces, people have access to, robotics and making, and they've done this in all kinds of cool ways. I always like to show the lowest entry point, but people have definitely used it with more, if they have more resources to do that. I just always like to say that you can do it with almost nothing. Although tape is expensive and we use a lot of it. We sometimes joke at Tufts, it's called the tape project because we use so much tape. Did you buy more tape? Did you run out of tape? Okay. Can everybody see Peter's chair here? Do my best reading. Jason said it's always super fun to do that. One of the things with picture books we also talk about with students, right? And I know some of you who teach reading are more expert on this than I do, but just how much the pictures are actually information as well. It's not just the text, but the illustrations help to tell the story as well, and things that we take from the illustrations, can be part of that. We have Peter's chair. We're seeing little bits of Peter. We see a dog and toys. And I'm not a professional children's book reader, but I'll do my best. Peter stretched as high as he could. There, his tall building was finished. Crash, it came down. Called his mother. You'll have to play more quietly. Remember, we have a new baby in the house. And so again, right, we're getting information from this chair. We're getting information from this page that isn't part of the text, right? As we see that the dog run through. Peter looked into his sister Susie's room. His mother was fussing around the cradle. That's my cradle, he thought, and they painted it pink. Hi, Peter, said his father. Would you like to help me paint sister's high chair? My high chair, whispered Peter. He saw his crib and muttered, my crib, and it's painted pink now. Not far away stood his old chair. They didn't paint that yet, Peter shouted. He picked it up and ran to his room. Let's run away, Willie, he said. Peter filled a shopping bag with cookies and dog biscuits. We'll take my blue chair, my toy crocodile, and the picture of me when I was a baby. Willie got his bone. They went outside and stood in front of his house. This is a good place, said Peter. He arranged his things very nicely and decided to sit in his chair for a while. But he couldn't fit in the chair. He was too big. His mother came to the window and called, won't you come back to us, Peter dear? We have something very special for lunch. Peter and Willie made believe they didn't hear her. But Peter got an idea. Soon his mother saw signs that Peter was home. That rascal is hiding behind the curtain, she said happily. She moved the curtain away, but he wasn't there. Here I am, shouted Peter. Peter sat in a grown-up chair. His father sat next to him. Peter, Daddy, said Peter, let's paint the little chair pink for Susie. And they did. All right, so just a good little story time for everybody on this wintry day. So maybe we can do this by folks doing raise hand or just do it in the chat. What are some things that you noticed about Peter? So Peter's our character that we're going to work on, things that he says, does, thinks, feels. If you're sidelined, you can type it in the chat. What do we notice about this Peter guy? Thanks, Jason. He's distraught or unhappy about this new sister.
Feels excluded.
Feels excluded. Everybody's working on it, focusing on this baby. Oh, good one in the chat. Jealous. Oh, I got it. You guys are so good. I'm not even fast enough. Jealous. He doesn't like pink. Who does, right? Takes inventory. Where is all my stuff?
He runs away.
realizes he's too big. Oh, runs away. Sorry, I talked over somebody.
Realizes that the chair is too small too.
Okay, I'm trying to combine a few of these because I'm not typing fast enough to get them all. Yeah, so we're getting this. We get a lot out of this book. A lot about how, we have just a few pages, but a lot on how this little boy feels, what he's thinking. Yeah, sorry, I have typos here. There we go. I can't have typos in front of teachers. Yeah. So this is often what we do first because we want to foreground this as a literary activity, right? These things are important. Maybe not all of them are things we'll solve with engineering, but we want to know who he is, how he feels. And then we might move on to say, how do we think about these as problems? And as engineers, what might we do to help solve Peter's problem? So I think we'll do this the same way so we can save our last few breakout minutes. What would you say the main problem? So what are some of the main problems that Peter's facing in this story? Kind of draws off the empathy map.
It's hard to grow up.
Yeah. He's feeling replaced.
Oh, I have another keep the dog under control. That noisy play is Willie's fault. Hard to train it. Yep. I think I saw in the chat he doesn't have his own things. You guys are such a good group. This is sometimes so painful over Zoom, but you guys are rocking it. So some of these are things that, might be best fixed with a discussion. We certainly don't want to say that we can engineer every problem. So his family having a discussion with him, and I'm condensing this process a little bit for time. So as a class, we would talk about this. Like some of these problems are things we should probably have conversations about. Like what does it mean to have a new baby? How would you do that? But as engineers, what are things that we think of, right? We could think of things that we could make or build that might help with some of Peter's problems. If you guys want to put them in the chat or unmute.
Maybe like a piece of furniture that can kind of grow up along with the child.
Yeah, so tackling that problem of he doesn't feel like he has his own stuff, or he doesn't have his own chair. Grow up with him.
Maybe they could have asked him right off the bat if he would help paint with them. Like they could have avoided it, as you know what I mean.
Yeah.
Foam building blocks that when they fall, they just.
So for quieter play. Locker curtains, that's great. I have not heard that one before. All right, so you guys have a good, it's at a list, right? Because so one thing, this is an interesting space for kids of like, are we doing something imaginary or are we doing something we could actually make? So someone was like, I would make a robot friend for him that would be really great. You'd be like, oh, that's a really interesting idea. That might not be something we can make in this space with the stuff we have, or it might be, depending on what's in your classroom. But right, we do this kind of funneling process of saying all of the problems count, all of them help us understand the book and the literacy. And then as we get to making, we realize that we can dive more into these. So what I'm going to ask folks to do now is I'm going to divide you up into slightly smaller groups so you can have conversations, and we will again use the Jamboard. So just think about what your idea would be for Peter. So kind of fleshing it out a little bit more and thinking of how, right, like you are literally selling this or making this for Peter. So how is it for Peter? And so I'm going to let you guys do this process. Depending on the age of your students, you might do more scaffolding or less scaffolding here, right? So we might help students figure out what criteria might be important to Peter with younger students, right? So color is important to him, how Willie is involved, things like that. And then we also push folks to think about how, which you guys are just doing a theoretical one, how are you actually going to test your design? So as a class, we might have a small doll that would represent Peter. So your chair needs to fit Peter, or your chair needs to fit Peter and the stuffy dog. You know, so as folks think about, as students think about the problems, they can think about like, how do we actually make this work? Because we actually want to make it work. Art is an amazing, wonderful thing, but this is not an art project. Right? So we actually want to push students to make something functional so that they iterate. That's always the big thing with engineering, right? We want that iteration. We saw even Amos, big, smartass MIT guy, did not get it right on the first try, right? So when we engage kids in engineering, we want them to do that iteration. And so if it's just a diorama or a something like that, there's no push to iterate. So you want to think about like, okay, if it actually has to fit this, if it actually has to keep this sitting upright or whatever criteria we come up with, so that as they make it and they're like, oh, he doesn't fit. All right, I need to redesign and try it. We're actually doing those engineering practices. We're looking at our design, we're analyzing it, and we're saying, hey, we need to make some changes here. And we always, of course, want to let students know what they actually have to work with. And that's actually, I could do a whole session on materials and kids in engineering. And I'm sure it sounds like lots of you have expertise here. But this also usually can't be the first time they've seen these materials because they're just too exciting. Right? It's too exciting to have endless tape and endless pipe cleaners and things. So right, we want to think about making sure students have had some time to play and experience them before we ask them to do a design challenge. So yeah, so I'm going to break you up into groups for about, I think we can squeeze in 10 minutes. About what what problem are you solving for Peter? What will you make it? How it work? How would you test it? And how is it for Peter? I know Google Jamboard isn't the best sketching environment. It does have that little, it does have those tools. It doesn't have to be perfect. So do the best you can, right? We're just trying to give folks the experience of what that's like. And yeah, does that make sense? Any questions? All right. Redo our breakout rooms. Nope. Retreat. Yeah, we're up to 30. I'm gonna do 6 of them. And if I see any lonely people, we will go from there. So it'll take about, 8 to 10 minutes to do that. And then we'll come back here, see all your cool, brilliant designs and wrap it up. All right, here we go. Welcome back all. Super short, right? A condensed, very condensed version of what we might do in real life, but hopefully this will give you a taste of what it's like. I think so that we have time for questions, I'm just going to go through these really quickly and highlight some of all the awesome thinking that I saw in them. So in room 1, we have a building block chair so he can build and resize, right? This is really cool. We have combining Peter's love of building and making with his need for a chair. Super cool idea. An adjustable chair with a color code and thoughts for the environment. And I also see a little bit of the parent perspective wiggling in here. How many chairs do we want to buy? What do they work? How do they work? So nice thinking there. Yeah, and so yeah, more of a brainstorming one, which is totally great with the time we have. Ways for him to customize it so it's really him. That's really cool. I think, right, we always talk about the color and his disdain for pink, which we could definitely talk in much deeper ways about, but I love this idea of pulling back from the color and really thinking about what are the other things that could be more there, more foregrounded. A tented chair. I'll give Peter some privacy, right? We're feeling this space that he wants that's his own. Could the chair also do that? Really nice connection. So obviously you do this, and we see students do this too. They really empathize with Peter, right? They've had this experience. They know what it's like, and they are thinking about these things as well. And it really taps into their resources and knowledge. Like, hey, I actually know a bit about how to be a little brother, and what little brothers might want, or a little sibling. And so it's another nice way to connect engineering to students, because it's saying, hey, your experiences are actually really helpful here in terms of engineering design. Yeah, so going for the color, who's it fit? It's quiet. It's also a toy. I love the Willy tunnel. I have not seen a Willy tunnel chair. I mean, I do this activity hundreds of times with different teachers and students. So there are just so many unique perspectives here. So great work all. A convertible chair and books and dog treats, right? That would be a really cool feature that is specific to Peter, right? We're not just saying like make a chair for a boy that's this big, but what would this boy want? He had toys, he had a dog. So great work all. And I will say, I know a lot of you are doing engineering, so you may have had this experience, but the planning stage is a really great place to have discussions with students, because we haven't made the idea yet. Once we've labored and we've taped and we've cardboarded, it can be really hard to let go of ideas where you're like, hey, why is that for Peter? Or did you just want to make the biggest chair ever? Or why'd you use balloons on that chair? I don't, like, tell me how that would help Peter. So like, this is a really nice place to have conversations with students. Well, would that really be for Peter? Might be one way I push back on a student's design. Or would that really fit in his house? Or what would happen if his little sister got a hold of that chair that you just covered with popcorn because you thought it would be cool? And so there's really nice space, but it's a nice space because they can still change their ideas. When we challenge people's ideas at the end, when they're all done, right, you're really defensive. You're like, oh yeah, no, that was a great idea. So it's nice to think about this. And we also, when we do it with physical things, we give, we challenge, we have a mid-design share out and ask students to to share out there as well, so that we can have conversations about what would make sense. You all have did that. This is some kindergarten students' chairs. Some of their ideas, obviously color came out really strongly for them. Having a chair for Susie as well came out for some of them. Let's just build everybody as many chairs as they can have. One that would fit Willie, so he and Willie could sit together. So a lot of the same ideas. And not everybody does chairs, right? Some people really focus on the toy part I've done. So I remember Jason made a whole set of toys when he did this the first time that he could play with. So there's lots of problems in the book and lots of different ways to solve it. And I think what you all can see is, right, you were doing those engineering pieces. You were the same as Amos was, right? You were thinking about Peter, thinking about the client, thinking about the context, figuring out what would make sense, and going from a big messy problem of like, how could we help Peter, to here's something I could actually build. You know, of course we were time constrained, so some people got to actually drawing it and envisioning it, and some folks were there. And all of these designs were valid solutions, right? Which is another really cool message for students, right? All of these different ideas, if they help Peter, are real solutions. So, you know, we take that kind of competition of making the best or the fastest out in this kind of a engineering project, and are like, these are all really cool. And these could all satisfy the thing. And if you were, you guys were doing it very easily, right? Just going back between the story, what does Peter want and like, and then also what could I actually make? And if you had materials, that would continue. What could I actually make this out of? What kind of materials could I actually make those blocks out of? So we only have 1 minute left before we need to do questions. We've done this in a lot of different kinds of books. This is a story of, if you've read the Mixed Up Files. So, right, this is just an example of doing it with a longer book and then a writing assignment where they really picked out a lot of different kinds of problems. Similar to you, right? We captured the problems. We had students actually pick different problems from that book, which was one way. Another way, like oftentimes engineering problems, I feel like get really competitive in a classroom. And so this, when students were working on different problems from the book, they could all give each other input, but they weren't feeling like, but mine is better. This teacher we worked with really wanted to do a lot with the writing. And so as they were designing there and requesting the materials, they really had to show, you know, like why would I do that? And then writing was also a concluding activity. And these were super fun. You've read Mixed Up Files, right? Kiddos hanging out in a museum. This is a guard distractor so that they could sneak around, a way to filter money out of a fountain, all kinds of communication devices while they were hiding out. And we just saw, well, what we saw in our research, which is all up on our website, just a lot of amazing conversations with students about like, well, what would the characters want? What would they do? Would they use wood? But the characters in this book don't have any money, so how would they pay for it? So we saw students easily, you know, it wasn't like, oh, we're doing the literacy now, and oh, we're doing the engineering. We saw them seamlessly kind of going back and forth. This was a space that they could navigate, and they were navigating all kinds of things. Could we make this? Is it feasible? How much would it cost? So, right, this wrapper, this space made a lot of sense to them, so they could do the kind of thinking, right? A lot of times, you know, in engineering design tasks, we list all the criteria and the constraints, and it has to do this and this. And so they're like, okay, what? But in this space where they're reading the book and they're creating them, it gives them a lot of agency. So yeah, so I'll just skip on there to the end. There's a lot more to novel engineering. We do lots of PD and courses and stuff on it. We have a book on it, but of course, with what you did today, you can run with that. But yeah, I will stop there for any questions or comments. Thank you all for being a great group. This was super fun.
All right. Do we have any questions from the group? Anything in particular that you're looking for or something like that? When I saw this, what I really loved is the fact of the freedom of innovation, leveraging low-cost materials, because again, I mean, the challenges that you have in your classrooms as well, of what can we do to go ahead and minimize costs, And I just thought it was really clever and it's a lot of fun. So I hope you enjoyed this as much as we enjoyed bringing it to you. I'm very happy to have Merredith with us, and she did such a great job. I want to tell you all, if there aren't any questions, you can go ahead and pop up. Okay, well then I'm going to assume no questions. We're going to move forward. I want to thank you all for attending. Again, you'll see in the chat, there's an agenda. That in the agenda is a survey. We would like to have that survey, and please go ahead and fill that out. It's just a hyperlink to a survey. And we'll have this video available on our website. Share with colleagues. I mean, if you enjoyed this, think of it how even your schools might enjoy it. Even some of your other teachers might enjoy it. Look, the price is right. We're bringing it to you with the right price, right? I mean, here's some content that's a lot of fun you can have into your classroom. So, and if you want your professional development time, again, reach out to me, jason.bruns@mnsu.edu, and look for our next meeting that'll be happening again or a seminar that'll be happening again on September 28th, this fall. So do I have an idea of what that might be? No, absolutely not. But we're going to come up with something good, and it'll be something enjoyable. And again, I want to thank you all for being part of this. And if there's not any questions, I hope you have a wonderful rest of your day. Otherwise, we've got a couple of minutes if you want to throw some questions out there. Please do.
Thanks all, and thanks to all the educators for all you do. We're so grateful for all of your work and dedication. We know how much work it is to be a teacher, especially these days, and you all are fantastic. And if we had been in person, there would have been snacks.
Right. And clever designs. So.
Oh yes.
Merredith, I do have one question for you.
Mm-hmm.
Did you ever run into or put a criteria on there that might have, at least with the one book that we read today, that really talked about how can we design something that'll help the overall dynamics of the home as well, taking consideration his little sister on the inclusion of that design, so make sure you're looking at it from a much more holistic approach?
Yeah, we've usually let folks, I mean, kiddos take the kid perspective, which we usually run with because we're doing this book with young kids. When I've done this book with adults, that's definitely come up as like a criteria, like it should help everyone. So it should be, making a new family set of furniture or different things. Right. And it's totally customizable to your goals, right? You could, as the educator, direct that conversation different ways depending on what you wanted to see happen. Great question. All right. Well, thank you all. Please email anytime, or if you do it and just want to show off your stuff. I like engineering project pictures, like other people like baby or pet pictures. I did this in my classroom. Totally love it. Totally love it. So if you just want that affirmation and that, like, oh, that's so cool. I'd love to see it. I'm going to run to my next Zoom meeting. And I hope y'all in Minnesota stay warm. Thanks for having me, Jason. This was really great.
Hey, thank you, Merredith. Everybody have a wonderful rest of your day, okay?